it in any designs that whenever we are having the requirement of giving the instructions. So based on the RISC-V, RISC-V stands for reduced instruction set computer. So it will have some principles itself. So it will have simple instructions. And that will be executed in a very effective manner. Okay, and it is very scalable. So it is used in microcontrollers and desktops and AI accelerators and computers. We can use this in these applications. And at where applications we can see means in embedded systems and in AI machines, and in industry level, we can able to do we can use this like in digital. So RISC-V wherever we are having the requirement to give the instructions, and in sensors also. So in sensors we are giving some instructions so that it will get the data capture and it will give that. So this is about the applications where we can able to use this. Okay, so now coming to the code coming to the code, we will see I will explain the code itself. It's a lengthy code, so we will start directly from code. So actually here I'm starting from my top module. This is my top module, where in this top module I'm having these sub files, that is register files, where we need to give the instructions, right? I'm having some instruction file, register file, and CPU file, everything that I'm instantiating in this top module. So this is my top module name, that is RISC-V, and I'm using the signals like input, clock, and reset I'm using. So yes, so I already told that, right? So this is the top module. So I'm instantiating my sub modules inside my top module. Okay, so where I have having the sub modules, like I have written the code for the program counter and instructions we are having, and register file we have, and instruction decode file also we have. So from there we are going itself. So where the clock is a periodic signal, where it will generate the clock, and it will particular time at positive edge of the clock, it will capture the input and it will give the output. Where we are using the reset signal, initially whenever we are starting our reset signal, we will clear all the data from our memory, and whenever the reset is going to be off condition, then we are going to be active, and we are doing the process of your module itself. And coming to the program counter, I'm using the 32-bit PC, and PC is nothing but here it is holding the current instruction address. Like whatever the current instruction we are going to execute, that address it is going to be hold. And PC next is nothing but it is going to store the next address of your instruction. PC is the present address. PC next is the next address of your instruction that it is going to be stored temporarily. Okay, and coming to this, okay, and coming to this, we are having the instruction memory, right? So whenever the instruction memory, from the instruction memory submodule, again I'm taking some two signals, main important signals, where I'm taking the memory like logic 31 down to 0 memory, and here 0 down to 15, that is nothing but here I'm creating the instruction memory, where all the instructions are stored inside this memory, so that your particular address you are giving here. Okay, so my memory, everything, my memory address will be stored inside this. So I'm having each my memory name is imem. So where I'm having 0 to 16 location, 0 to 15 locations, that means overall 16 locations. Each location will have 32 instructions itself, 32 bit of data. Okay, instructions I will have. And where here I'm using the a small instruction like 16 words of data we are storing. And if you want to select a particular address, here you are using the current address and the next address storing, right? So by using this, you can able to store particular address. But suppose here I'm giving the locations of 16 locations. So if you want to select the locations of address, if you want to select the address of 3 to 6, 3 to 6 locations, so you need to give like 3 to 6 locations. I need the address itself. So whenever you are giving that, so actually you need to give like this: PC of 5 to 2. Like from this address to that address, I want the instructions whatever that was stored inside the memory. So we can able to take that. Okay. And instruction whatever this we are using, this is nothing but this is your current instruction whatever you are going to give. And coming to the register file, here I'm having one register file. Okay, where it is register is of 0 down to 32, where register is nothing but temporarily it will store, means it will store the data. And here I'm using 32-bit. Okay, 32-bit register you are using. Okay, and 32 locations we are having. And always if you are not giving any values, it will hold the zero value. Register can able to hold the zero value. Next, coming to the decoder. So you are using the instruction decoder. Actually, we are having the sub modules. So just I'm giving the normal explanation that what we are written inside that. Whenever we are going to that particular module, again we can able to see how we have written that logic itself. So we are taking the important signals. Okay, not all the signals we are taking. What the basic signals that we required to your top module, that depends on basically depends on that inputs only. You need to trigger your another outputs. So for that basic important inputs you need to write in your top module. Okay, so here coming to this, I'm using 5-bit of, yeah, here this is the instruction decoder, where this instruction decoder will extract your files. Okay, here we are extracting our files itself. So where we are using the read pin. Okay, where we are using the read pin, so that is the destination register, means where from where you want to read, that is destination source. You are having source and destination. So RD is nothing but destination register. RS1 and RS2 is nothing but your source registers. You are having two source registers, that is RS1 and RS2. These are your source registers 1 and 2, and your destination register. Both are 5-bit. Okay, and here you are having IMM, that is 32-bit. That is nothing but immediate for adding, for addition. You are doing for addition, right? So whenever you are doing addition, some instructions that is generated by the CPU, I already told you, right? So CPU will generate some types of instructions like do addition, do subtraction, do loading operation, do shifting operation. So that can be of anything. So whenever you are giving IMM means, it is telling that do the immediate operation. Like for example, do the immediate operation of addition, do the immediate operation of subtraction. So it is telling like that. So it need to do respond immediately. Okay, and you need to get your source value, and you need to get your register, sorry, source value too. Okay, register. And here you are performing the ALU, immediate addition you are doing. ALU means immediate addition you are performing here. Okay, so whatever the RS1 and RS2, you need to read the values from your register. Actually, for the register, here doing two types of operations. One is write operation and one is read operation. So here you are writing inside your registers. Here you are reading the values from the registers. That what operation was, what is the instruction it has given, what is the value it has written inside the register, that you are reading it. Okay, and next, yeah, here you are writing the logic, where what you are telling means, here you are taking like assign keyword. This is data flow. So we are following like a data flow. So it is a continuous assignments where it execute very continuously, and after completing one statement only, it will execute the next statement. Until that, it will block the current statement. Means after, if this statement is going to be executed, After completing this statement only, the next statement will comes to the execution. If the first is not completed, then the second will go to the block state. Okay, so that's why we are using the assign keyword. And here I'm giving the instruction where you are having here, you have mentioned your instruction, right? Current instruction, that is your current instruction. So you are telling that you want to get the instruction, you need to give the address. See, what we are doing means, first we have created one memory. In that memory, we are having some address. In that address, we are having some particular instructions. So, to execute that particular instruction, you need to give that address itself. Which instruction you want to execute, you need to give that particular location address. So, here I'm giving that. Here I already tell you, right? If you want to get some particular instructions, you need to give your address of your instruction. Okay, so here we are giving your address, present address, current address of your instruction. So you are telling that you want to get the instructions from fifth location to second location. So whatever the instructions that have loaded inside the 522, that instructions you are going to be executed. That is your current instruction. And next up, you are having two sources, register sources, you are having two. So for the two sources, you are giving the instructions. So what are the instructions you are giving means, you are having overall instructions of 32, right? In that overall 32 instructions, particularly you are selecting source instruction and two source instructions of particular instructions you are selecting. What are the particular instructions you are selecting? 19 to 15 and 24 to 20 instructions you are selecting, like source and two source instructions. You are selecting two different types of instructions you are selecting. Okay, and destination instruction also I need to give, right? Destination is also having 32 bit of memory locations. So that also which instructions you are going to follow, that also you need to give the address itself. So this is also particular location, this is your wish, you can select any particular instructions that you are already assigning inside your logic. So here I'm giving some particular instructions from 11 to 7. Okay, and here I'm telling that I want the immediate operation, immediate instruction I want to do. That is like what it will do means, it will extend your instructions itself. So immediate instruction, what you are doing means, here, yeah, here I'm using the concatenation operator. Okay, where your immediate instruction is of 32 bit, right? So what will happen means, it will add overall bits and it will generate your 32 bit of data. So what you are telling means, you are telling your 20. Okay, so you are giving your 20 instruction, like where you are giving here. So and you are telling your instruction value will be 31. Okay, and your instruction value should go from 31 to 20 again. You are telling, that means what you are doing means, just you are extending your instructions itself. Okay, and now you have written something. You told that from these instructions, from this address, I want these instructions, you have told that to your CPU. So what you need to do, you need to read that values, whether it is giving the correct instruction or not, you need to read that. So that is your RS1 value and RS2 value. This is nothing but you are reading your values. You are reading the values from your register files. Okay, so you are reading the value from your first source and you are reading the value from your second source register. Okay, so this is what about your instruction decode, means how your particular instruction you are selecting, that is about instruction decode. And now go to the PC update. So yeah, so here you are giving your current PC current address and your current next address, right? Your register. So your instruction current address and your next address you are going to give, right? So here what we are doing means, so here we are using always flip-flop, where it is a sequential, where the address is going to be generated continuously, like parallelly it need to go executed. So parallel execution means nothing but procedural block, where the procedural block will execute in the always block, always model. Okay, It is a flip-flop, always underscore flip-flop at the rate of posage of clock. Means nothing but you are giving the particular clock itself, so that for every positive edge of the clock, it need to capture your inputs and it need to generate your outputs. That output should be constant for complete one clock cycle. Okay, so for positive edge of the clock, you are giving the input or negative of reset. So whenever you are mentioning this, it is nothing but, we already know that we are having two types of sequential circuits, right? Synchronous and asynchronous, right? So whenever you are mentioning that posage of clock or posage of reset, means nothing but your the reset value, whatever you are giving the reset is also independent of clock. It is not depend on clock. It is independent of clock here. Clearly, we can able to observe that here we are giving separately clock and reset. So the reset is not depending on clock. That means clear that it is a asynchronous circuit. Okay, so if of reset, that is nothing but if my reset value is 1. Okay, if my reset value is 1, my present address, my current address should be 0. Okay, nothing should be generated. And initially register need to start from initial onwards, 0 onwards. So what it need to give, from initially it need to start with I value as 0. Means your registers are, you are created, how many registers you have created? 0 to 31, overall 32 registers you have created, right? So you are telling that you are using the for loop, and you are not telling some particular register, you are not telling. It need to increment automatically, and you want to take, if your reset value is 1, you are clearing all the data, all the address, all the instructions in all the address. Okay, means from 0 to 31 you are clearing all the data. Okay, all the instructions inside your memory, all the instructions from 0 to 31 you are clearing everything. That is about this thing. Okay, and next, else means your reset value is 0. Okay, so if your reset value is 0, then it need to perform the operation. Means the present address should generate your next address. Currently you are in second location, it will generate the third address, third instruction, and the third instruction is your current state. Now it will generate the fourth. Now 4 will become your current state. The next will be 5. Now 5 will become your current state. Next will become 6, like that. Okay, so current is 0, right? Next is 1. Now 1 will become current. Next will be 2. Now 2 will become current. Next will be 3, like this. So it need to cover all the address, that it is having all the instructions inside that. This is nothing but your address you are going to be update here. You are updating your address. Okay, and next, simple next means you are going for next, right? Simple next logic you are writing. Okay, how many jumps you are doing, means you are directly going for current plus 4. Actually, what is your current one? Whenever your reset value, initially it will come with 0, so you are clearing all the data, so your PC is 0, right? So how you will get your next address? Next address means here it will substitute the PC as 0. 0 plus 4 means 4, right? So the PC, the next address will update with 4. This I will update with 4 now. So now the PC value will become 4. Now again here it will substitute 4 here. Again 4 plus 4, 8. So now it will update with 8. Again PC will update with 8. Again 8 plus 4. How many times it will repeat, means until you are going to your 31 locations, it will continue this sequentially, means serially it is doing this process. Okay, next, you are doing immediate operation of ALU operation. That is nothing but addition operation you are performing, right? Simple ALU operation you are performing. So whenever you are performing simple ALU operation, it is nothing but, yeah. So you are giving the combinational block. Okay, you are doing combinational block for your addition itself. So you are having overall always blocks of two types. One is sequential and one is combinational. Where the sequential, if you observe the sequential, means you are executing less than equal to. Whenever you are seeing the combinational, it is in the form of equal to form. What is the difference between this less than equal to and equal to means? This we are calling it as non-blocking and this we are calling it as blocking. Where the non-blocking statements will execute in a parallel way where this all the always block, coming to this always block or whatever the statements you are having, all statements will start at a time. Okay, all statements will start at a time. Coming to this, whenever you are using always combinational, whatever the statements you are using inside this combinational, due to this equal to blocking operator, first it will execute the current statement and then it will go to the next statement until your current execution is completed. If your current statement is not completed, then it will block the next statement. That is nothing but all the statements will execute in the serial way. They all not executed in the parallel way. Okay, next. So here I'm using always that is nothing but combinational logic we are writing here. That is combinational logic is the serial execution, whereas sequential logic is the parallel execution. Okay, so case, we are using case statements. Case statements, we already know that we will give some condition here. Case statement and if condition, both are same. Both are same. How means, like we are giving if statement and if the condition is true, then we will go for true. Otherwise, we will go for false, right? Similarly, case, you are giving some instructions here. If it is getting this value, it will execute this statement. Otherwise, it will go for default and it will execute this value. Similarly, like else. Okay, it will cover all the statements. And case, end case, and here you are giving the instructions. How many instructions you are taking? 0 to 6 instructions only we are taking. Okay. Yes. So in these instructions, your first instruction is this instruction. First instruction is this 7-bit, right? You are giving the how many bit instruction? 0 to 6 means 7-bit of instruction. For suppose some instruction we have given. Okay, some instruction we have given. So if you are giving this type of instruction, any instruction you can give. If you are giving this type of instruction, then it will go and execute this value, that is output of your ALU. What is the output of your ALU? You will get whatever the value you are reading from your source 1 register. Whatever the value you are reading from your source 1 register plus your immediate addition. This both will be added and then you will get the output of your ALU. For suppose if you are giving this type of instruction, 7-bit of this type of instruction, then it will take the value of your source 1 register and source 1 register, whatever the values you have read from your source 1 register and source 1 register 2, that both will be added and that output will be generated to your ALU. For suppose if you are not giving these two instructions, other than this you are giving other instruction like 0, 1, 2, like 15, 18, 20, 25, like any instruction you are giving. So it will go for default and it will give the output as 0. So that instructions are not found. So output will become 0. This is how we are writing the operation for your ALU. So first you are adding your source address with your immediate address, and the second source value with the source 1 value and source 2 value are added, and we are generating value that to the ALU. Next. Okay. Next we are giving the sequential logic. Okay. Like okay. Okay then. So here we are giving some type of logic, that is write back logic. So what it means, you are giving some flip flop and taking the positive edge of the clock, and this will work with this is a synchronous. Why I'm telling as a synchronous means the reset is depend on clock. Okay, this is synchronous. And if of not of reset, that is nothing but if your reset value is 0, we are using logical and operator. That means this condition should be satisfied and this condition should be satisfied. If both condition will true only, it will execute this statement. Okay, otherwise it will come out of the loop. Okay, so if your reset value, otherwise it will not execute this block, it will go for the other block. Okay, so if your reset value is 0 and if your read is not equal to 0, not equal to 0 means assume that it is 1. Okay, it is 1, then only you can read the data. So reset value is 0 and my read pin is 1, then if of whatever here I have given my instruction, so if of my instruction equal to this value or if my instruction equal to this value, you have given two types of instructions. If your instruction is either this or if your instruction is either this, you are giving logical or operator. That means nothing but if either the instruction value is this or this, any one is okay. Okay, if any one of the instruction is getting, then for suppose if I have given this type of instruction, this type of instruction means it will add the values of source and destination registers, right? So whatever the value it is adding, it will give it to your ALU operation output, right? So whatever the output it is giving here, that output you can able to copy here, that will be given as the read value from your register. So that data will be read from your register. So actually this value you are storing inside your register, that value you are taking out from your register. This is your read operation. So what it is writing and what you are what you have done, you are taking it in a clear manner. Okay, and next is, okay, we are writing the printing purpose. So I want to print the values itself. So if I want to print my values just for printing purpose in the console, I'm giving this. What is my register 1? What is my register 2? What it is writing? What it is reading? I want to take that. So I'm taking that always flip flop at the rate postage of the clock. If my reset value is 0, okay. If my reset value is 0, I want to print what is my current address, what is my current instruction, what is the value of register 1, register 2 and register 3 whenever I'm reading the data. Okay, whenever I'm reading of whenever I read register 1, read 2, read 3, I will read for 3 times. What will be the values I will get? 3 reads. Okay, and you need to give some immediate address, right? Like you need to load the data, right? We are giving the, see, here you are giving instructions when to load, when to get the next address, and when to do the, for this instruction you are telling to increment the value, and if the instruction value is this or this, take the ALU operator, or if my instruction is this, give this instruction. So you are telling everything for the CPU, right? From the register you are telling that, so that you need to give the values, right? So we need to give the values, like what load the values, we need to load the value. So we are loading the values for this. So this is for, this will go for addition. Okay, it will take for addition and it will do that. And this is the second value you are driving, 32-bit, and this is the third value, and this is the fourth value you are driving. Okay, so now we will see how it is going this. And coming to your test bench, simple test bench we are taking. So just I'm initially starting my register clock with 0. So initially my clock is starting from 0, and if my reset value is 1, it need to off, the output will be 0, right? So, and periodically I need to generate the clock is the periodic waveform, so it need to generate continuously. 5 nanoseconds it will stay positive, 5 nanoseconds it will stay negative. So complete one clock cycle is 10 nanoseconds. Okay, and here I'm giving the path of my RISC-V. So this is my module name, right? I'm giving this module name, and I'm connecting this signals with the DUT signals. Okay, next, initial begin. So I'm repeating the values for 2 times. how many times you want to repeat, you can repeat. Okay, so I'm repeating first 2 times. I'm taking my positive edge of the clock. For every positive edge of the clock, the reset value is 0. What are the values it is taking, I need to observe. And whenever my repeat is 10, so I want to observe my what is the values it is going to be taken. So after that, I'm giving some dollar finish to stop the execution, means to end the simulation. Okay, this is about my test bench. So to run all the things at a time, I'm using my run.do file where I'm giving the commands of my tool where I'm running this code. So here these are the commands of my tool itself. So first, initially, whatever the commands, these all the things I'm writing, I'm taking this all the commands from my Verilog library work. Okay, and first, before executing this, first I need to compile my files of my design and of my test bench. So first I need to compile that whether these both files are executing in a proper or not. Okay, like syntactical issues, or is I'm missing any semicolons, or is I'm not covering anything itself, means if I have declared the inputs but I did not connect it at any place. So like syntactically from top to bottom it will check that, and it will give whether it is the code is 100, means compiled successfully or not. Okay, and coming to this simulation, I need to run the simulation. So where we are giving the uh, module name of our simulation. So my module name of my simulation is this module name I'm giving here. Okay, so uh, where I need to write the files. A minute. So here I'm giving the module name, TB module name, where from this module name only, here you are giving your DUT path, right? From this module, it will go to the DUT file itself. Okay. So the simulation will execute in the top-down approach. So like that, we are giving your test bench. And I want to add my waves itself. So for that, I'm having one command, that is add wave, so that we are adding all the signals into our waveform. And to run the file, we need to use this command, that is run on. Okay, this is the command name. So what we need to do means just copy this path, current directory path, and go to our tool. Just we need to give the yeah. So just what we need to do means just current directory. I'm changing my current directory, and whatever the commands I have written, I need to give that command file. I am giving my command file name. Okay, so automatically it will execute, it will run, it will compile, it will add everything, it will done in your automatic way instead of we are doing manually. Okay, so this is how it is generating the waveform. Please repeat it for 2 times. Clock reset. Okay, so first I will show it in the transcript. Okay, so here I have took only for 4 things. I did not give the another instructions, so that's why it is not getting. So first see here, first my current address. Okay, PC is nothing but your current address, right? So first my current address is 0. Current address is 0. Whatever the instruction I have given, here I have given my instruction, right? Yeah, here I already told you that PC will start from 0, right? 0 plus 4. it will take, right? From initially it will start from 0. So 0, 4, 4 plus 4, 8. So it is incrementing with 4, right? Here we are incrementing for 4. So 0 plus 4, 4, 4 plus 4, 8, 8 plus 4, 12. So like that, the PC value will be incremented. Okay. And so here, whenever your PC is 0, means current instruction. And here I'm giving my first memory instruction. First memory instruction is 500093. So this is what we are giving instruction. First instruction we are giving. So we need to take it from 3 pos, right? For what you are doing, you are printing your current PC. What is your current address? My current address is 0. Initially, when it is 0, when your PC is 0, when your PC is 0, whenever your reset is 1, right? Whenever your reset is 1, your PC is 0. Can you get any register values? Can you get any register values if your PC is 0 and if you're giving any instruction? Will you get any register value? No. I told my register I should not get any register values, right? So that your register values are all zeros. All 3 registers. Okay. Next, it will go and substitute 0 plus 4. Now it is updated. The next instruction is 4. So here you are substituting 4 here. Now your PC is becoming 4. So whenever your PC is becoming 4 and you are giving some type of instruction. Okay. So I'm giving this type of instruction. That is A000113. This is the instruction I'm giving. Okay. So whatever the instruction you are giving, this is your instruction. You are currently giving this. Okay. From this instruction, what is the data? It is reading from the register that we need to observe, right? So what it is doing, just we need to get these three types of registers. So for this, already you have written the logic for this, right? So already you have written the logic for this. That is nothing but whenever your instructions in this, so that your ALU should get, so that you are giving into your registers, right? So whatever the ALU you are getting output, that ALU output you are giving to your registers itself. Okay. So here what we are doing means, whatever the instruction you are having, first that you are adding with your immediate instruction. Okay, means this thing it is happening. So after doing this, whatever the value it is generated, that value you are driving to your register itself. Okay. So here I'm giving that value to this. Okay. So if you want to see it in the waveform, we can see here. Okay. Yeah. See here. In this, it is filtering your source 1 and source 2 here. From your data only it is filtering. From this data only it will filter. See here. So for the first one, whenever your clock is positive edge and whenever your reset is 1, if you are giving any data also, your PC value is 0. So if you are giving any data also, you don't get anything itself. Your register values will be 0. Right? Next, whenever your clock is 1 and whenever your reset value is 0, now your PC, now your PC is 0. Right? So your next address will be it is going for 4 itself. 0 plus 4 it is going. And next, the instruction whatever you are giving is this instruction you are giving. And your I value you are giving 20, right? Here already you are giving your I value. Here. Okay. So here you are giving your I value. That is 20. And what is your, from these instructions, after 5 you are having 0, 0, right? After 5 you are having 0, 0, right? That is your source 1. Okay, that is your source 1. And before that you are having 0, 5, right? That is your source register 2. Okay, and now you are reading, your read pin is 1. Okay, what you are giving here, you are clearly telling that my read pin should not equal to 0, right? So your read pin will become 1 itself. Okay, see here, your read pin will become 1. Okay, until you are going for 11 to 7. So your read pin is 1. And what is your immediate address is? Your immediate address is 5. Okay, that is from source 2 you are getting. Your immediate address is 5. So what it will do means, what is the value of source 1 value and source 2 value, where it is 0. Like here, from here you are getting, right? From here you are getting, see here, from source 1 and source 2 you are assigning your values to your register source 1 value and source 2 value. So it will not give any output. Why it is not giving any output? Why? Because here you already written that, here we have told that I should not get any register values. My register value should become 0 if my reset value is 1. You are telling clearly, right? So that's why it is not giving any register values. Okay, and your ALU value is 5 itself. Okay, why it is becoming 5? Source 1 plus immediate value. So your value plus immediate value, sorry, this you are taking, so that you are getting 5. Sorry, you are getting RS1 value with immediate value, right? What is your RS1 value? 0 plus 5. 0 plus 5 means what is your output? ALU output. Your ALU output is 5. Okay, now go for the next combination. So here 4. Okay, your present address is 4, your next address will be 4. Okay, and what is the instruction you are giving? This type of instruction you are giving. And your I value is constantly you are maintaining 20. Why? Because here you have by default here you have set it 20, right? So it will set only 20. Okay, if you want you need to change that. That is the instruction. Next step, initially your RS1 value 0 0, your RS1 is 0, and your A value is, your RS2 is A. Okay, and your read operation is 2. So now you are doing second read operation. How many reads you are doing? You are doing 3 reads, right? Read 1, read 2, read 3. Now you are doing second read. Okay, whenever you are doing second read, so what is your immediate address? Your immediate address is 2. So what you need to do? You need to add your RS1 plus immediate. This RS1 plus immediate. What is RS1? 0 plus A. A. A is your output value. Okay. Next. Now we are going for the another case. Here my present address is 8 and my next address is 12. 12 means nothing but in hexadecimal we are representing in C. Okay, and this is my next instruction I am giving. I is same, and what is my source 1 value? Source 1 value is 1. Already one read is completed, right? And second read is also completed. 1 plus source first RS is 1, second RS is this 2 it will take, and now you are doing the read operation of 3. Okay, third read operation you are doing. Okay, so your immediate address is 2. Okay, your immediate address is 2 now. Why it is 2? Here it is instruction, it is 2, right? So your immediate instruction will be 2. Okay, and your RS1 value will be 5. Okay, your RS1 value is 5. Yeah. Yes. Here you are generating RS1 registers, right? From the RS1 registers, you are getting into the register. From the RS1 registers, you are taking from 19 to 15 values, and here you are taking 20 to 24. See, you are having the binary bit of data, right? Binary bit of data. Let me show you. It is taking from 19th position to 19th position to 15th position. RS1 is taking from 19th position to 15th position, whereas RS2 is taking from 24 position to 20 position. Let me show you. Sorry. Okay. So see here. Here you are having RS1 position, right? So coming to this RS1 position, your instruction is 32-bit data, right? In this 32-bit data, yeah, in this 32-bit data, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Till here it is 15, right? Now see. You are taking from 15 to 19. Till here 15, right? Right? 15, 16, 17, 18, 19. That is nothing but 4 zeros, 1 1. See here. Okay? Coming to RS2. What you are taking? 24 bit to 20 bit. So till here already 9 is completed. 19. Yeah. So now coming to the RS2, it is 20 to 24. Here it is 19, right? 20. Yeah, okay. Here it is 90. 19. 20, 21, 22, 23, 24. That is 00010. 00010 it is taken. Okay. Now coming to the read. What is the read? 11 to 7. 11 to 7. Count from 11 to 7 positions. Here 15, right? 14, 13, 12, 11. Okay. 11, 10, 9, 8, 7. So it is 00011. That is this value. So from your instructions only it is taking that bits itself. Okay, it is filtering that. Okay. And next, coming to this immediate, I is 20. Coming to this immediate, okay. Coming to this immediate, what it is taking? Your I value 20. And next, it need to get the instruction of 31. So 31 instructions it need to get. And in that 31 to 20, it need to get from this. So here 31 to 20. Here all zeros, where from 31 to 20 it will take zeros to 10 itself. That's why it is becoming this value. Okay. And coming to this, RS1. What is the RS1 value? Whatever the source one you got already address, that you need to copy to register. So what is the source one address you got? Source one address that you are going to copy for your RS1 value. That is nothing but okay. Yeah. Okay. So whatever the RS1 value, right? Yeah. So now coming to here, you are taking your RS1 and immediate. So here itself, your RS1 is 5, your RS2 is A, okay, where you are getting from this RS1 and RS2. From this, you are getting this RS1 value and RS2 value. That is also a binary bit positions, okay. And after getting this, how you are getting ALU value? A plus 5. 10 plus 5 is 15. Means it is the value it is taking as what is the 8 bit of data you are having? Instruction 8 bit. Instruction 8 bit, that is nothing but 0 to 6th position. 0 to 6th position you need to observe instruction. Okay. Yeah. Radix binary. So 0, 1, 2, 3, 4, 5, 6. It is 0, 1, 1, 0, 0, 1, 1. 0, 1, 1, 0, 0, 1, 1. This is the instruction you got, so that it will do plus of RS1 value and RS2 value. that is nothing but 5 plus 10, so that you are getting 15 value, right? So whatever the instructions you are giving, according to that instructions, it will continuously increment that values. So whatever the instruction values you are giving, that will select that RS1 value, RS2 value, immediate value, everything from your instruction, and it will filter that, and it will take the values and it will add them. This is what the RISC-V processor is doing. Every addition, subtraction, or everything operation that you are coming from your CPU, everything types of operation will done by this RISC-V processor. Okay, according to your instructions, it will select that. So select this, select that, you are telling that. Okay, so this is about RISC-V processor. Okay, so waveforms are not, you can't able to see the waveforms. I have written the code in the form of system log. Okay, so yeah, so okay, I will show the waveforms again. Okay, yeah, okay, fine. Okay. Can you please confirm me that now the waveforms is, can you see my waveforms now? Yes, can you see my waveforms? Yes. No. Hello. Yeah, okay, fine. So let me show the waveform again itself. See, this is the waveform that what you are getting. Okay. So here I am not taking another instructions. So I am taking only few of my instructions. So see here, whenever your clock is 1 and whenever your reset is 1, you don't get any output. Okay. Whenever your clock is 1 and whenever your reset value is 1, so now you are doing the started operation. So after some time, what you are doing, your current address is 4 and your next address is going to be 8. So what is the instruction you are giving? This is the instruction you are giving. The instruction is of 32-bit data. And coming to the I, you are giving the I value constantly as 20. Here you can see. Here you already give the I value as 20. Okay. So, and here also I gave the value. So coming to this, how you will get the instruction means, first you are taking this instruction, right? And you will get the read source, register source 1 and register source 2, where register source 1 will take the values from 15 to 19 bits of your instruction. So coming to your instructions, uh, yeah, coming to your instructions, whatever the instruction, the RS1 value, okay, see your RS1 value, the RS1 value will take the value of 15 to 19. See here, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, right? Now 15 to 19, 15, 16, 17, 18, 19, all zeros, right? So that's why your RS1 is 0. Next, RS2 is 20 to 24 bits of data you need to take from your instruction. So that is 1, this RS2. RS2 I will show you. Yeah. See here, what is the value it is taking? So here you are taking off till here it is 19, right? 20, 21, 22, 23, 24. 0, 1, 0, 1, 0. That is nothing but 10 value. Okay, this we are taking from your instructions only. Next, RD2. What is the RD value? You need to read the instruction from 7th position to 11th position. 7 to 11. 7 to 11 means 0, 1, 2, 3, 4, 5, 6, 7. Here write 7, 8, 9, 10, 11. That is 0, 0, 0, 1, 0. Okay, that is 2. Okay, next, immediate is also where location. Immediate you need to take from, yeah, immediate you need to take from 20 to 31. 20 to 31. Observe this. Here it is 20, right? Here it is 20. 20, 21, 22, 23, 24 until 31. All zeros, 1, 0, 1, 0. That is nothing but 10. So this is your immediate answer. So your RS1, RS2, RD, immediate address, RS1 value, RS2 value, everything you are getting from your instruction only. Clear? So whenever you are doing this type of operation, and here itself, observe this, your instruction should be 0 to 6 position. 0 to 6, in the instructions you need to get this type of values. Now see 0 to 6. 0, 1, 2, 3, 4, 5, 6. What is the value? Double 1, 1, double 0, double 1, double 0, 1, double 0, 1. Yeah. What it is value? Double 0, 1, double 0, double 1. Right? 0 to 6. Double 0, 1, double 0, double 1. Is this value is matching? Yes. So it will do RS1 value plus immediate value addition. So that you will get the output value. RS1 value is 0 plus immediate value is 10. 0 plus 10, 10. You will get the ALU. Okay. Now go for the next sequence. For this sequence also, next is 8. Next, current is 8. Next will be 12. Okay. You are giving some type of instructions. Same. You are giving I value as 20. What is your RS1? Your RS1 instruction will need to take from 15 to 19. Okay. 15 to 19 means this, from this. 1, 0, 0, 0, 0, 0. That is 1. Again, 2 means 0, 1, 0, 0, 0, 0. That is second instruction. Next, read instruction is, what is your read instruction? 11 to 7. So from 11 to 7, here you can observe 0, 0, 0, 1, 1. That is 3. Okay. And next, coming to your, yeah, coming to your immediate value. Your immediate value is, from this you are getting your immediate value, that is 20 to 31. See, 20, 0, 0, 1. Okay. Yeah,